Looking at the end of section 2.2, this has to do with determining the points at which functions have horizontal tangents, and also using points to find average rates of change. So let's look at just a function of any type. If I have a function that looks like this, the slope of this tangent line is positive. That might be like positive 3. The slope right here, that might be positive 1. The slope right here, though, what's the slope right there going to be? 0. And that's a horizontal tangent line. The slope right there is about negative 1. The slope right here, once again, it's 0, and it's a horizontal tangent line. Slope right here is about 1. Slope there is about positive 1/2. Another horizontal tangent line with a slope of 0. So what would we do to find where we have these horizontal tangent lines? We would like to know the x value that causes it to happen. That's what we're trying to do. We're trying to find what is the x that makes us have a horizontal tangent. Any ideas on how we could figure that out? What's the slope at all these horizontal tangents? What is something we do to find slope with the functions? Derivative. So if I take the derivative, what will I want the derivative to be? 0. So that's what we're going to do. We're going to take the derivative here. Once we have that derivative, what do we want this derivative to equal to find a horizontal tangent? 0. So I set the derivative equal to 0. And we're going to figure out what is the x that makes the derivative 0. So we just keep factoring. Keep going. And so we can see here that the x's they're going to give us 0 are going to be 0, 2, and negative 2. So those are the x coordinates. The question, though, says determine the points at which the graph has a function of the function has a horizontal tangent line. So I know the points are going to be the following. They're going to be 0, comma, plug back into the original. Why am I plugging back into the original? What am I finding? The y value for that x value. So 0 minus 0 plus 2, so it's 0, 2. There's a point where we have a horizontal tangent. Plug in 2. 2 to the 4th is 16. 2 squared is 4 times 8 is 32 plus 2. That's negative 16 plus 2. That's going to be negative 14. If I plug in negative 2, I'm going to get the same answer because these are to the 4th. It's an even function. So I'm also going to get negative 14. So those are going to be 3 points where the function has a horizontal tangent line. And in fact, they're going to be the only 3 points. If I go to y equals and I type in this function, I'm going to check this answer. I do a zoom 6. Here's the way the function looks. I'd like to see the bottom of it, so I go to my window and I make it go lower. So here's what it looks like. So I want to check those points. I think that when x is negative 2, I have a horizontal tangent. So I'm going to check the slope there. Second trace, calculate number 6, dy dx, find the slope when x is negative 2. And it tells me when the slope is negative 2, here's my point, and this is the slope. Well, this is negative 8 times 10 to the negative 6. That's scientific notation. So that's negative 0.000008. That's 0. That's a slope of 0. The calculator actually tries to measure the slope by using pixels, and it's not really as accurate as calculus is. So we're going to find dy dx when x is 0. That slope should be 0, and it is. And the last place where our slope should be 0 is at when x is 2. Our slope should be 0, and it is. Can you see those are the only 3 slopes, only 3 points where we would have horizontal tangent lines. Okay? All right, this one's going to be a bit more difficult. So this time we have f of theta equals radical 3 theta plus 2 sine theta. So in between 0 and 2 pi, we're trying to find where we have horizontal tangent lines. What is the first thing we do? Find the derivative. So f prime of theta. So in this case, theta is x. Okay, you just got to think of theta as x. So what if we had radical 3x? What's the derivative of that? It's kx, so it's just going to be radical 3, just k. The derivative of 2 sine theta, 2 cosine theta. So that's our derivative. The derivative tells us slope. We want to have a horizontal tangent line, so we want to have a slope that's 0. So solving this, I get negative radical 3 over 2. Does anyone know the angles that would make that be true? If you don't, you could draw a picture. We know cosine is adjacent over hypotenuse. Our missing numbers would be 1s. You should know that if we have 1, radical 3, and 2, it's a 30, 60, 90. What's across from the 1? 30. So this angle is going to be 180 minus 30. What is that? 150. And what's 150 in radians? 5 pi over 6. So 5 pi over 6 is one of our thetas. Our other theta is going to come down here. It's going to be 180 plus 30. That's 210. What's 210? (21) times 30. 7 pi over 6. I meant 21 times 10. So it's going to be 7 pi over 6. 7 times 30 is 210. This is just a 30-degree angle. So 7 times 30 is 210. That's right. Now we have to find the actual points though. So this is like our x-coordinate. We need to also find our y-coordinate. So I got to plug it back in. So I got to plug in theta as 5 pi over 6. So radical 3 times 5 pi over 6 is going to be 5 pi radical 3 over 6. Kind of weird, but just multiply it by radical 3. And then plus 2 times the sine of theta. Well, here's my angle theta right here. What's the sine right here of 5 pi over 6? 1/2. Times 2 is just going to be 1. My other point is 7 pi over 6, comma. I multiply it by radical 3, so that's 7 pi radical 3 over 6 plus, plug in 210 now, or 7 pi over 6 rather. What's the sine of 7 pi over 6? What's the sine right there? Negative 1/2 times 2 is going to be minus 1. So those are going to be the 2 points, xy, xy, that would result in having a horizontal tangent line. Okay. The next part is average rate of change. Average rate of change is just slope. So if I have 2 points, I'm going to have to do y2 minus y1 over x2 minus x1. C just means constants, that we're given 2 constants, and we're given some function. So we plug the constant in to find the y value. Plug the second constant in to find the y value. It says find the average rates of change for the function over the indicated interval. Compare this average rate of change with the instantaneous rate of change at the endpoints of the interval. Okay, so this is our interval. This is my C sub 1, C sub 2. This is my start point, end point. So if I want to find the average rate of change over that interval, I need to know my points first. So if I plug 2 in here, what do we get? 2. What if we plug 3 in there? What do we get? 7. So these are our 2 points now. To find the average rate of change, we're just going to have to do 7 minus 2 over 3 minus 2. That gives us 5 over 1, and that gives us 5. 5 is the average rate of change. The instantaneous rate of change, we just did that in the Kahoot. What's the instantaneous rate of change? The same thing as slope, which is the same thing as derivative. Okay? So now I have to find the derivative of this. So the derivative is going to be 2t. So I want to find the instantaneous rate of change at 2. So f prime of 2 is what that would be. 2 times 2 is just 4. That's our instantaneous rate of change at 2. And then f prime of 3 is going to be 6. So this is the average rate of change over the interval. This is the instantaneous at the first endpoint, instantaneous rate of change at the second endpoint. Questions? All right then, let's take a look at this last one. Here's our function, negative 3 over t. First thing we want to do is find our average rate of change over the interval. So what do I need to do? I need to find the what? The y values. Good. So I need to find 1 comma something and 2 comma something. If we plug in 1, we get negative 3. If we plug in 2, we get negative 3 halves. So to find our average rate of change, we're going to have to do negative 3 halves minus negative 3 over 2 minus 1. Well, this is just 3 minus 1.5, basically. It's 3 minus 1.5. That's 1.5. 2 minus 1, that's 1. So I'm going to have 1.5 over 1, so that's just 3 halves. That's our average rate of change. What do we do to find the instantaneous rate of change? We have to find the what? Find the derivative. So I have to find f prime of t. Well, to do that, I'm going to have to think of this as negative 3t to the negative 1. So what's that going to be? 3t to the negative second. So that's 3 over t squared. So now we're going to do f prime of 1. That just means plug in 1 for t. 1 squared is 1. That's going to be 3. F prime of 2, 3 over 2 squared. That's going to be 3/4. So that's f prime of 2. Instantaneous rate of change, instantaneous rate of change, and average rate of change. Okay? So your quiz is going to be on Wednesday. So all these concepts are going to be on there. So we need to know our basic differentiation rules. You need to have these 5 things memorized. You need to know how to do rewrite, differentiate, simplify. You need to know how to do that with more complicated problems. Remember, on a problem like this, you want to just square that out first and then do a rewrite. Then you have to be able to find the slope of the tangent line at a point. Remember, that's just your derivative. Find the equation of the tangent line. You have to know the point and the slope to do that. And then lastly, the thing we just talked about now, finding that place where we have a horizontal tangent. We take that derivative, set it equal to 0, then plug those x values back into the original to find out the y values. And lastly, average rate of change and instantaneous rate of change. Okay? So if you understand everything on this notes page, you'll be in good shape for the quiz.